Hello again, Kipsters. Today we're going to be talking about water. We're going to be talking about water as a solid, a liquid, and a gas. First, we're going to be talking about water as a solid. Water as a solid is called ice. Ice is formed when you take liquid water and you pour it into a mold, and it gets so cold that the molecules slow down and hold their shape. So like when I look at these pieces of ice, I think about an ice tray. I put water into this ice tray, and then when it is frozen, the water takes a solid form, and it becomes ice and holds its form. Now, how ice is made is you think about water has little itty bitty molecules. These little molecules, when they start to freeze, slow down, and they're getting really cold, and so they want to get closer and closer together. So I think about solid, these little dots represent those molecules. And now when they get so slow, they're going to hold the shape that they were frozen into. Just like an ice cube has this shape or a different shape, that's how the water will stay frozen. Okay? That's water as a solid ice. Now, water as a liquid, I think about comes from like the sink. It flows, it's your drinking water. Okay, so I've got water right here. Okay. These molecules in this water are moving a little bit faster. They're a little warmer, so they have a little bit more energy. And so they're spread out more than the ones of the solid. I think these words are a little backwards, but that's okay. So my solid is really tight, cold molecules really tight together so they hold their shape, where liquid has more energy, and so it's able to move a bit more freely. Now, for this part of the experiment, I'm just gonna add a little soy sauce to my water so it's easier to see. I'm just gonna add a few drops here. It's not gonna change the water too much. Let me stir this. I'm gonna stir this up a little bit. It's still the shape of, it's still water, it's still liquid because my soy sauce is also a liquid. Okay. Now, the thing with a liquid is it's gonna take the shape of any container that you put it into. So my ice, it's holding its form outside of its container. It's staying like this, where if I were to try to pick up water, I can't pick it up and it holds its form. It just creates the space that it's in. So when I think about, I'm gonna actually move this over to my sink. Okay. So when I think about pouring this water, right now this water is in a large round container. I'm gonna move it to a small, tall container. So as I pour it, it's now forming to the shape here. Okay. Now I can pour this into any different container and it's gonna hold its form. Now with ice, if I were to take an ice cube, I have ice here. It's frozen into this form. It's hard to see, okay? It's frozen into this form. If I put it into here, it's not taking the shape of the container because my molecules still have very low energy and are still holding the shape that it was frozen into. All right, so now we've talked about a solid, we've talked about water as a liquid, and now we're gonna be talking about solid as a gas. So what I'm doing here is, in order to see that, I just turned the heat up on some water on my stove. And so I've got some water starting to boil here, and we'll talk about that in just a moment. Okay. So now water as a gas has a bunch of energy. And so because these molecules have so much energy, they're spread out all around. They're just going super fast. And so they don't hold the form. Just like a liquid can hold form, gas is just free. It is going so much energy. If I have enough gas, I can put it into a space and it'll hold that form. but it's a lot harder to do than liquid, because liquid I can pour, where gas is free flowing in the air. Just like the air that we breathe in a type of gas. We breathe oxygen. There's other types of gas in the air where all these molecules are moving so fast, we can't really see them because they're so small and they're so spread out. So when I think about a solid melting into a liquid, and then that liquid evaporates into a gas where those particles are so far away from each other because there's so much energy, they're bouncing across each other, and they're bouncing, and they're just moving so super fast. So now we're gonna come back over here to our water and see if we can see the gas kind of coming off. You might see it in the form of steam. Let's see if we can see some steam coming off of our pot here. It's a little hard to do right now. Okay, I can see it here. I'm not sure if you can see it, but steam is really, really hot. So you don't want to be touching steam because there's so much energy, or that heat is creating a lot of energy. And so that heat can actually burn you because it is so hot. So although steam seems like a mist, be very, very careful and cautious. We'll come check back up on that in just a moment. Okay, so you've learned about a solid, water as ice, water is a liquid, and then gas, water as steam. Okay, these are different types of forms or matter that the water takes. Okay, now you're gonna do an energy break before we come back to our water. So you are gonna be acting and moving your body just like you are either water as a solid, a liquid, or a gas. Now, if I am a solid water, my body is gonna be a molecule. That means I have low energy and I'm really tight and I'm not moving a lot. So if I was gonna say solid, your body is gonna do this. You're gonna go and just stay really tight and not move and just hold. Good. If I'm gonna say water as a liquid, you have a little bit more energy. You can kind of move and flow, move your body, reach tall, reach low, reach wide. But you're flowing just like you would act like you're some water with your body. Okay? Now if you're gas has high energy and you're going crazy and you're moving around a lot because you just are so energetic. All right, let's see. Kipsters, your turn. You're now going to become a solid, a liquid, or a gas. Get ready. On your marks. Get set. Solid. Ooh, you should be moving really, really, really not at all. Gas. You're going to move high energy. Come on, do it with me. High energy. Oh, liquid. Ooh, become water. And moving. And a gas. Oh, super energy. And a solid. Oh. You're going to hold your form. Don't move. All right, let's see if you can do the next few on your own. You're now liquid. Are you moving like water? Flowing, medium energy. Solid. Don't move. Super still. Just be like ice. And liquid, you're water again, flowing just like a stream or the ocean. And your gas, super high energy, moving super fast all the way around. Fill your space as much as you possibly can. Move. Wow. All right. Now that you have some of that energy out of your way, we're going to be talking about another state of matter called a polymer. Say it, polymer. Okay? A polymer is a little bit different than water or liquid and a solid. So I'm going to have some cornstarch. If you want to make this with me, I've got some cornstarch. And then I just have a little cup and I'm going to put some water here in this in just a moment. But a polymer, like cornstarch and water, cornstarch's molecules are actually pretty flat when you lay them down. And so you've got these flat molecules that are layered into kind of chains on top of each other. And so when I have this water with my cornstarch, the cornstarch molecules are flat. And so let's say I push on it. I'm gonna have to push through these flat molecules, and it's gonna be really hard. But if I move slowly, some of these molecules can kind of move to the side and make it feel like a liquid. So we're gonna be looking at how can we create one substance that acts both like a solid and a liquid. So I have my cup here and I have my cornstarch. I'm gonna put a little bit of water. I don't need a lot. I've got maybe a tablespoon right now of water in here. Okay. And then I'm gonna put some cornstarch. I'm just gonna use the same thing. Okay. I'm gonna do a little bit more cornstarch than water. I just need my cornstarch to kind of be moving in, being able to kind of stir in to my water here. I'm gonna actually get a different one. This spatula is too skinny or too soft. Okay. So as I mix this up, my cornstarch and my water start to mix together. I'm gonna add just a little bit more water. Don't do too much, just a quick splash. If you do too much, you're gonna have to reset and you're gonna have to do it so over and over again until you get the perfect consistency. Growing up, I called this oobleck. And so right now I'm able to stir it, but it's actually pretty hard to stir because it's just at that perfect consistency for us. All right, so right now I have, oops, I'm gonna try to get a better angle on this. So I've got my cornstarch and my water right here. Okay, so what I'm gonna do is I'm just gonna move my finger through this slowly. It's acting like a liquid. It's falling off my fingers, no problem. But if I were to come at this pretty quick and tap on it, I can't actually get through it. It's acting like a solid. Because what's happening is with these flat polymer molecules, is as I'm pushing in, when I push really fast, they stay really stiff against each other and they don't allow me to push through. But when I'm able to move slow, each of these moves out of the way just a little bit to let it act just like water or a liquid. Okay, you can add food coloring to this and make some oobleck and mess around with it a little bit. And it's kind of like slime, but all you need is cornstarch and water to make this polymer. And now I've got it all over my hands. Ew. All right, Kipsters. I'm gonna come back over here and check to see if we can see any of our gas. I see some gas rising off of that. Ooh, I see some steam right there. That's water as a gas. Okay. All right. Well, thank you, Kipsters, for joining me today. If you have any questions on how to do this experiment, please have your parents feel free to reach out to me and we can talk through it more. Talk to you later.